So how is everybody doing today? Good. Awesome. Yeah, so my name is Marco. I'm a data scientist here at Salesforce IQ. And yeah, today we're going to go ahead and talk about how to actually get very, very, very close to putting your models on production in a very quick amount of time, a fraction amount of time. So I'm basically going to guide you guys through how, so using airline sentiment data set as a proxy for customer satisfaction, essentially, how would you set up something of the sort as an engine that can take your email interactions, which, right, so if you think about, so for example, right, like your sales representatives, that one of the main points of contact with the customers that we have is the emails that they're actually converting, right? And from this, we can actually see, oh, did a customer stay? Did a customer leave for some particular reason? What kind of responses are we getting? Like I said, today's demo is really showing you how to put this machine learning model onto production using some simple text classification techniques. Cool. So first of all, I want to talk about Apache incubating PredictionIO. So actually I started off at PredictionIO about a year ago. Actually worked on this text classification template that we're going to be using today. And yeah, so now it's actually, we've donated, Salesforce has generously donated this to the Apache Foundation, and it's going to be available for open source for everyone to use and to actually contribute. Cool. Awesome. So the main idea here, right, so when we're actually trying to put these machine learning models on production, right, so a lot of the times, a lot of people like to get very focused on what models we're using, right, and that extra maybe 1% increase in accuracy that using one model over another will use, right, but that's, right, if you think about it, I mean, you can really find almost any model implementation that you can possibly think of. I mean, a lot of the models that you'll end up using in life are already implemented for you somewhere, right? But the biggest pain point really is getting your data into a format that we can actually use to train a machine learning algorithm, right? So a lot of the times the data that we're getting is a mess, right? Like, and if we're a company who's serving various different customers, right? Each customer's data is going to be slightly different, right? And so PredictionIO gives you a platform to basically help you get these models up and running, get the data that you need up and running in the correct format. That'll basically make it easy for you to just feed it in to whatever machine learning algorithm that you want to use. And also, as soon as you do your plug-in chunks into the PredictionIO platform, you can actually go ahead and deploy it as a service like this, right? And this is an extremely, extremely powerful concept, right? Because one thing, yes, training a model. Now, how are we actually going to use this to deploy scores? And the cool thing is that these scores are actually given to you in real time, as we'll see. Cool. So. So, over here, I'm going to go ahead and talk about the main abstraction here at PredictionIO. Just something called DASE. D-A-S-E. D stands for data source and data preparator. So, right, so this is basically talking about, right, where are we pulling our data from? What are we doing to actually put it into a format that we can easily just plug and chug into a machine learning algorithm, right? So, as I said, our data is oftentimes, right, so if you think about what machine learning algorithms are actually doing, right, they're essentially taking some arbitrary dimensional space and mapping it back over to some real number from which then we can, decipher some sort of decision rule based on, right, so in the case of classification, right, as you can think, our points are, these little points scattered out in p-dimensional space, right, and so we're just producing a score to actually draw a line and be able to basically say if it lands on one side of the line, boom, boom. So if it lands on one side of the line, classify to over here. If it lands on the other side of the line, classify over to the other class, right? But unfortunately, our data usually isn't structured in this format. So I'm going to go ahead and, so continuing on with DOSI. So A stands for algorithm, which is, as I said, right, machine learning algorithm that you can use. You can think logistic regression, naive Bayes, SVM, neural nets, whatever you want to use to actually, take this input data, these input vectors, some vector, and produce a result, right? Serving. Now, our serving components basically, right? So when you actually go back and talk to your customer and interface with your customer, right? A lot of the times, there's actual meaning to what the scores that we're producing have, right? Or in the case of classification, right? I mean, you can abstractly think of it as a mapping to, to this high-dimensional space to a finite set, right? But this finite set actually does, right? So for example, when we're looking at email data and say you want to build a spam filter, right? Whether it's 0 or 1, right? There's actually a very interpretable meaning behind that business logic that tells you, hey, is this spam or is this not? So the serving component actually helps you put this business logic into play, and it also helps you, right? So if you have multiple algorithms getting trained in your engine, which I will talk about in a sec, right? How do I go ahead and compose these scores? Cool. And then finally, relevant to the previous talk, evaluation metrics, right? So one of the key parts of data science is actually going through and saying which of my models should I actually use, or which is the most effective, which is actually empirically based on the data that we're given, and usually using some sort of cross-validation technique. You can use different techniques as well, but in particular we use k-fold cross-validation here, right? That we can somewhat determine basically what that EPE, that expected prediction error, is, right? Based on the notion, right, that our model applied on data that hasn't been seen before, right, that should produce some significant indication of the actual of how it's going to perform on future data, right, which is what we're interested in. Cool. And now, basically, this pipeline describes, I think, how any machine learning system that you're going to build can be abstracted into these steps, right? We start out with our data here, then, right, this is getting stored off into some database, right, like Postgres, some DBC, right? So then this data source, then we need to pull this data from this data source, prepare it into a format in which our algorithm 1, algorithm 2, doesn't matter, right? They're both going to need to have the data prepared in some format for which they can actually use it to train this model. And once it's in the we've trained all our algorithms, produced our predictions, right? Then we need to know how do we want to combine these predictions, and how do we want to actually, give some implement this business logic that is behind these predictions, right? So.
Okay, cool. Thank you. Awesome. Dope. And then, of course, the evaluation here is a side step to actually decide which model that we're going to want to interface with our customers or the users of your application. Cool. So over here, we kind of show how this is. This shows how things are integrated into PredictionIO, right? So first step here is actually getting our data into the event server, which is essentially a huge metadata store that it stores all your data and tags different metadata about it, so you can actually go through and put the correct data into your engine. And then, our data source produces our training data, and the data preparator goes through and takes that training data, puts it into a format, again, that you can use to then feed into your algorithms. Awesome. So I actually want to go through and show how to do this with PredictionIO. So PredictionIO makes it very, very, very easy, as you'll see, to get these to get this this model actually running into something that's actually you can query on production, right? And so we start PredictionIO with very simple PO start all. So PredictionIO is built on top of Spark for the data processing, HBase for the metadata store, essentially, and Spray as well for the REST API that we're going to need to use to actually query our models that we have trained in real time. Cool. So now, looks like everything started. Let's make sure that my event server is here. Awesome. It's alive. In case you guys, it's alive. I'm reading this correct. OK, yeah. Cool. Now let's make sure it's alive. Yeah, I have an aquarium at home, and sometimes the fish. I'm kidding. That was a bad joke. Cool. We're all ready to go. All right. So now I actually want to show you how this abstraction translates over into PredictionIO, right? So PredictionIO is written in Scala. And here, the main component I want to show you is awesome. Cool. So now here, we have a query class, right? So when we actually want to query the models that we have trained, we need some sort of representation of what this query is. So remember, today I'm going to show you how to put together this customer satisfaction engine based on emails, right? So here, in this case, what is our query going to be, right? It's based on some collection of emails, or right? So or a collection, or just a text file, right? Right. We should be able to produce a score of whether or not this customer is satisfied or dissatisfied, or just kind of hanging in between. Now next, our predicted result. So this is what we're actually going to output to our customers, right? So here, category represents what is their sentiment based on, so the proxy example based on the actual airline sentiment tweet, and what is our confidence in this prediction, right? So you can think of this as the probability that it's actually falls to that class, or our predicted probability that a customer is dissatisfied with our product, or that the tweet was labeled as negative. Cool. And then the actual result. So when we have our training data, we know exactly what our, so we know whether a customer has left or whether they've stayed, right? So we actually know the actual result that is associated to an email, or to in this case the airline tweet. Cool. And then over here, we actually have our engine. And so this engine, as you can see here, we have to specify what our data source is, D, what our preparator is, still D, A, what algorithms are we using. So in this case, I set up a naive Bayes and logistic regression algorithms, and also how are we going to put together all these results, and how are we going to display them to our user. Cool. So are there any questions thus far? Nope. OK. Awesome. All right. And so here I want to show you the data that we're going to be using today. Can everyone still hear me? No? Sure. Thank you. Cool. So here, so this data set originated from one of the, you can look it up on Kaggle. It's an airline sentiment. It's one of the free data sets available there. So here I've already put it into a format that is ready to go. Oh, nice. Awesome. Cool. So yeah, so here it's actually already been put into a format that the event servers is ready to take, right? So as you can see here, we have several tags onto there. So here we have some of the event time, right? So part of the stuff, when you're actually building these things out in production, you're going to want some sort of notion, right? What data do I want to include when I actually go through and train the model? Well, this metadata tag is like actually going to let you filter the data based on these different, right? So based on the different event times, which is basically denotes when this event came into your server. Cool. Entity type, target entity type, event, tweet over here, right? So as you can imagine, your data store is probably going to have, not just these email correspondences, but there's going to be, right, as you can imagine, maybe you're collecting your phone conversations and somehow actually taking that frequency and mapping it over to something that makes sense in the computer, right? But we need a way to actually be able to pinpoint the data that we want to use to train the algorithm. So in this case, we're trying to use text data to gauge some sort of level of, well, of how satisfied a customer is. So, which brings us to the properties over here, which, as you see here, we have two properties that we're going to need to actually feed this in to our model. So first is a text which contains the tweets, and next is the label here, which just contains basically is this a neutral, positive, or negative? Is this a negative, positive, or a neutral tweet? And they actually had someone go and like hand pick them, or like go through the tweets and like kind of gauge what whether or not they were in one of these three categories. But I do want to, and I'll talk about this one a little later, right? But as you can imagine, you may not have these things labeled. So one engine, for example, could be helping you out with actually producing some sort of categories or finding some latent variable, latent categorical variable for you to actually assign your emails in as they come. Cool. Now, next step is to actually import the data into our event server. Cool. Awesome. So PredictionIO, it lets you. Yep. Sorry, one more time. That is completely up to you how you actually go through and implement your data preparator, right? So you basically just need to plug in these 4 steps, right? Where you're pulling your data from, you need to specify, where it's coming from, what data you actually want to look at, and then in your preparator stage, right? So whatever data you ended up including, and I'll show you the data source right now in a sec, just to kind of see how that works out. But yeah, I mean, it's completely dependent up to you. But yes, if you put some logic for missing fields, right, you just need to implement that in, and then once it's into the preparator, right, you just need to hit your PO build, PO train, PO deploy, which is a sneak peek. But yes, you can handle whatever use case you particularly have. Cool. So I'm going to go ahead and create a new app here. Let's call it okay, yeah. It's fine. Thank you. Dope. Awesome. Cool. So now we have a new application, and as we see here, it'll show up again once we go ahead and do PO app list. Cool, so here's our access key, which is basically a unique ID tied to our application. And here's the actual ID of the app and the name of the application itself. So now let's go ahead and import data for our particular application. So here we just need to specify the app ID, which is given here as 3, and input airline tweets, JSON. Whee. And so this is doing a batch import, and I used a Python script to create, to basically put my CSV data into this JSON format, this event format. Cool. So now it's actually imported. So just I guess I'll show you the script right here. So it's just a super quick script. There's a Python SDK, PHP SDK, Ruby SDK for you to facilitate a lot of these things, depending on kind of what you're more comfortable with. But right, we're just parsing out the CSV, putting it into a very simple format, and nice. Cool. And now I want to show you this data source. So one of the cool parts too about PredictionIO, so it started in an open source philosophy, and one of the big components was the notion of a template, right? So you should be able to just, right, so a lot of these use cases like lead scoring, recommendation, text classification is a super general one, right? You shouldn't have to recreate a lot of this logic for these things. So we have community contributed templates, right, that you can actually just pull from and actually modify very, 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 very quickly to actually get something running super quickly. So over here, I pulled our text classification template. And literally had to modify basically how to basically tell it how to map the labels out correctly and what the event names were, right? So I have some email data as well. Well, I don't have it in here, right? But I can always import the email data into the app. App ID 3. Awesome. And I'm not going to have to worry about the email data, the email spam data getting mixed up with my airline sentiment tweets, right? Because again, we're doing this filter over here where we just want the tweet data. Cool. All right. So I'm going to go ahead and now that our data is imported, now we're going to actually go ahead and build out and deploy this model. So first step into actually getting your model into production is to do PO build. So this basically takes your engine code, compiles it, does all that. And just give it one sec. Awesome. So as we see, our engine is now ready for training. So next step, right? So I've shown you the data source. So our preparator here, right? So the data source itself. The main abstraction here is going to be this thing called observation, which contains three things: label, which we've already seen, text, and the category. So the category is going to be used later when we actually want to tie right, the float label that we've represented this category with to the business logic, right? So whether or not this customer has had a negative reaction, neutral reaction, or a positive reaction to their particular airline experience. And over here, we have two algorithms that we can put it through. We have one that's just doing a, well, actually, let me show you the preparator first. And here, our preparator is actually going to go through, right, it's going to take the label, the text, and it's going to go ahead and split the text, apply this TF-IDF transformation over it, and basically do the data processing that we need to in order to actually be able to use this in a machine learning model. So here it's just using a simple hashing trick to embed our words into a num features dimensional space, and then from there, right, we can either put it through this naive Bayes algorithm, right, which we have a regularization parameter here, lambda, and LR algorithm, which also has our regularization parameter here. Cool. So let's go ahead and hit PO train. And so by default right now, I'm setting it to go through the logistic algorithm implementation. Awesome. So as you can see now, our model has been trained, and it's ready to be deployed. Sweet. And whoa. Cool. And now as we see, this guy's been deployed, and we can actually take a look at information regarding our engine. Cool. So here we have the instance ID, variant ID, and what engine was used to train it. Tells us what data source, what parameters were used for the data source, preparator, what preparator was used, the preparator parameters that are used, and also the algorithm that's been used alongside with this regularization parameter here. Cool. And oh god, where was the curl command? All right. Actually, let me just pull it out right here. Sorry, I have the curl command saved. Cool, and as you can see here, we actually have a little quick start for this for you guys to get started. Nice. Awesome. So obviously, I like speed and fast motorcycles is different. But so here, as you can see, it's predicted it to be in the neutral category, and it's also given us what the probability is, relative to the 3 categories. So now let's go ahead and say something else just to kind of show you. Delta overbooked my flight. Now I have to drive to Los Angeles. Awesome. Cool. So clearly I wasn't very happy about having to drive to LA that weekend. Yes, because they did overbook my flight. And hey, let's actually check different airlines. So as you can see, actually, we're actually just making curl commands here. And this thing's just responding based on the model that was trained in real time. So see, Virgin America, positive. Sorry. You guys want to try United? All right. Neutral? Delta. Delta's actually been my least favorite. Granted, it was that one experience was very bad. Surprisingly neutral. Cool, and finally, American Airlines. This one's for sure negative, by the way. Yeah, American Airlines sucks. Sorry, no, I'm kidding. Cool. So as you can see, so super easy to get, from this one template, get my data in. About the toughest part was actually parsing that CSV and putting the data into the JSON format and actually modifying those 4 lines. And from there, I just, again, hit PO build, PO train, PO deploy, and holy crap, now you have a predictive engine that you can actually query in real time, right? And you can do a lot of stuff with this too. Cool. Whoa. So are there any questions before I continue?
Based on your experience, like in this case here, what type of confidence range would you consider significant or important?
It's, yeah. So generally here, so like there's not, so if you look at the tweets, they're not like super informative. So I think a good confidence score here is like, I mean, the distribution's roughly going to be uniform throughout for some of these queries. But right, as you can imagine, as you actually, like in email data, when there's a lot more context and like, right, so it's a good question. I would say in this case, just from what I've observed, roughly like that. I mean, so long as it gets past that like 40 line, it's like pretty good. But again, we don't have a huge amount of observations, and as you see, like the tweets themselves aren't. Head 30 and. Right, so if you look at these tweets, right, they're, yeah, I mean, it's, yeah, so roughly what I observed basically from this data set is like a lot, the actual confidence results tend to be like more on the uniform distribution side, but yeah, slight preference over 40 is generally going to be pretty, means like, okay, I'm pretty confident on this, right? So there's like 3 classes, right? So you can imagine, yeah, I don't know if that was a great answer, yeah. Wait, what? Okay, cool.
This is a super basic question, but in your model, you're able to take in multiple algorithms?
Yes.
The Bayesian algorithm and then whatever other learning algorithm
Yes.
you want it to put into. So how does the output work? Does it sort of combine the two and sort of come at a...
Yes. So good question, actually. In this case, I believe it's, so yes, so great question. So let's actually go back over here to, sorry.
No, mine was a really simple question. It's like, if we used one algorithm here, but what if you had 2 learning algorithms you wanted to put in? Then, in which case, how would that result be affected? I don't mean to paraphrase what I said.
Cool. Just so everyone hears. All right, cool. So yeah. So if we look at here, right, so here we produce a sequence of predicted results, and then we're basically just saying, oh, take the result for the most confident one. Yeah. But I mean, as you can imagine, you can put different business logic depending on how you want to approach this particular problem, right? Any other questions thus far?
Yeah, one more over here.
Just kidding.
Me? Okay, fantastic. So, great example, loved it. Bias is one of the biggest challenges we have. You know, you gave a couple of examples in your demo. One was obviously you have tweets or emails that might come in. We know by definition that most tweets and emails are going to be negative and generally negative.
Mm-hmm.
The other one you mentioned is as a human employee, I might come in and have to judge those. Clearly, I am motivated to judge them positively. So bias is a huge problem we face. And whether it's machine learning or it's reporting, we tend to want to report what our bosses want to see.
Mm-hmm.
How do you fight that in terms of this? How do you combat bias?
Huh. I mean, that's an excellent question. I don't have a good answer to that right now. Let me think about it, but I would imagine at some point, right?
Give
if
me
like,
my card,
yeah, yes.
We'll have a beer over it.
Sure.
Yeah.
I mean, I would say, right, like in the case where, you know, the bias comes in at the, you know, when you're actually labeling these things, I mean, that's going to be pretty hard to kind of lever. I don't have a good answer. Let me, yes.
That's our next Series A funding. We'll make a lot of money off that.
Okay, awesome.
Yeah, cool.
All right. Yeah, no, great question. All right, cool. Are there any other questions in the audience before I continue? One more, it's fine.
It's okay. I was just curious about how you might use this with a cohort analysis of sorts. Just to sort of think of a historical trend to really understand. I mean, he asked about bias, but a lot of that could also be looking at one factor and be able to predict where the next step would be based on previous data.
Mm-hmm.
I know you're not specifically talking about solving that, but I'm curious to know how you think about that, about a historical view of predictions, because a lot of this is based on a one-time data set. What happens now when we have multiple data sets of the same factor or the same object?
So I mean, there are a few ways that you can encode time, right? One thing is actually including it into the features themselves, right? So say, I mean, one example would be like, say, emails for this user over this week, emails for this user over this week, right? Emails, right? So you can have kind of put together these sort of vectors, and then at that point, right? I mean, even just thinking about it as simply as a linear regression, right? Then you're just doing a linear model over, right? Using these time features. I mean, that's the simplest solution. I mean, it depends on how you want to model that, really. Like, I mean, that would be, I mean, just plugging it in, I mean, more directly is just, right, like, you're feeding this matrix of features, right? You can encode that time information, right, on different data points in space. I think that's at least one simple way that you could, that you could incorporate that, right? And, right, so here, these event times would allow you to do that, right? Because we could say, hey, and, right, so we're using the hashing trick, so we can even, like, right, so if you think about it that way, like, we're going to have these huge vectors, right? So you can actually control that maybe a little bit more depending on what your computing capabilities are going to be, right? But
this is still a lot faster.
yeah. And yeah, I mean, it depends, right? So that's going to go in, again, to that algorithm and how you want to actually represent this data, right? And even that data source preparator, like, I may not necessarily be using a model that requires me to embed my data into a real vector space, right? Like, I could actually be using something like, I mean, like random forest, right? I mean, it doesn't matter, right? At that point, right? We can input both categorical and numeric features into this model. But I mean, yeah, so it depends on how you would want to kind of phrase that. But yeah, I mean, that would go, I would say, roughly into the data preparator, right? And data preparation, and also how you actually choose to model this, right? But if you encode these time into your features in that way, right? You are in a way getting a sense of how how these things change over time, and including that into your model, right? All right. Awesome. So now I'm going to go ahead and kick this guy out. Whee. Sorry, I'm just going to deploy it here. All right. So now another cool thing here. And so actually, this is kind of going back to your question on the data collection, right? So in this case, there were people that were, going through this data, reading the tweet, and then saying, oh, is this positive, negative, neutral, right? But as you can think, there might be a better way of actually being able to do this, right? So you can think, right, potentially you could run some LDA model, or run LDA, and have this LDA basically produce clusters, or cluster assignments, right? And in that case, that kind of takes out that different component, or the component of, right, human error. But now, when it comes through to actually, right, so now that I want to actually make a new prediction and all I'm getting is an email, then how the heck do I connect the prediction from LDA, and how the heck do I then use that label and, right, feed it into my next query, which is like okay, now predict where I want to send this, this customer to, right? So here we actually introduce the notion of an engine variant. Cool. And so one of the cool parts about PredictionIO is that we can actually deploy multiple engines, deploy them as services on different ports by simply modifying. So right, so I've already built my engine, don't have to go through this again. And now, sweet. So that's up. So this engine.json, right? So once you've actually gone through and built out and built your template, right? So there are different parameters that you can say and which parameters that you want to use, right? For the predictions, and right, you don't have to rebuild this again. It'll actually just parse this JSON for you when it goes through the deployment in the training phase. It'll actually go through, parse this JSON, and map the parameters into there. So as you see here, here we're only using this LR model, and here, as you see, we have this reg param here. Likewise, if you looked at the preparator, parameters that we were using, we had this ngram, none features, and svpmi. Cool. So now, let's say I want to do A/B testing, actually. And I want to test out two different algorithms. Say naive Bayes, and here we're going to set our lambda. .0, cool. Awesome. So much quicker. All right. Cool. So now we can actually just go through the training process again. This time specifying this new this new set of engine parameters. It'll go through, do the training process. Awesome. Cool. Engine JSON, and this time I'm going to go ahead and deploy this on port 8001. Dope. So now as we see here, we have this engine deployed using the logistic regression, and this engine deployed over here using the naive Bayes model. And we can actually take a look at our new engine over here. So as you see, this engine right here is now using this naive Bayes algorithms. And likewise here, we're still going through, oh no, oh yes, oops. Oh, Stoops, okay, cool. Thank you. Awesome, yeah, so as you can see here, this engine right here is now using this LR model, the logistic regression, and over here, yay, we have our queries. So now, as you can see here, we can actually still talk to one model. Awesome. American Airlines, and you can still talk to the old model. So this one, yeah, awesome. Cool. So as you can see now, we've actually deployed two different models, two different engines on, yep.
So I was just wondering if you could try a different string. So could you try, I really wanted to drive to LA today, thanks Delta. Like, does it detect sarcasm?
Well, sarcasm's in general pretty hard.
No, it's not.
I really wanted to drive to LA. So no, it doesn't. All right, yeah. Yes, both models scored positive. Maybe that thanks is getting you. So yeah, I think in general, like with NLP problems, that's going to be sarcasm. I mean, something like sarcasm is going to be extremely hard to. Yeah, I mean that's a very tough thing to actually get at. Cool. Awesome. So driving point here with this, right? So now we have these different multiple engine variants. They're both deployed on different ports. So first of all, what's one use case of this, right? Now you can actually A/B test on your customers, right? Send one side of the group over to port 8000 and send another side of the group to point 8001. Another thing you can start doing is, yep.
I'm assuming you can keep on importing data and retrain your model and reevaluate.
Yes.
So is there an easy way to prune data? So say I assume that I found out that this week of data is probably bad. So is there an easy way to prune that and then retrain, reevaluate?
Yeah.
How
It's actually, yeah. So over here, if you look at this over here, right, so we have an instance ID. So if for some reason at some point you notice that your data has been corrupted, right, you can actually always roll back to a previous model and deploy that model. It'll actually do the deployment. It'll undeploy the previously held model and deploy, it'll undeploy the new model that now has been corrupted with bad data, and go back to the old model. It'll do the deployment, undeployment seamlessly, right? So it'll actually it'll undeploy it from the port and do it for you, a millisecond fraction at a time. But yeah, it'll take care of that for you, and you can always go back in time and actually start using. And then at that point, right? So it's not going to solve at that point your data's been corrupted, but it'll at least give you time to look into what went wrong and how can we actually fix this, right? And also, right, so this event time that we have when we throw our data into the event server, we can always, so I mean, if for some reason, right, we couldn't actually go back and filter this database, but we know, right, but we know that week n in the year was the one that was corrupted, we can always make sure to filter that data out using this event timestamp.
So all the model versioning is stored in HBase, I assume?
Yes.
So, from a really basic perspective, if you had let's say, a major traumatic issue that would really not be the norm, you could then say, well, this machine this was trained on a very spurious set of data. We may need to go back because this isn't really emblematic of what we normally do.
Yeah, right. So I mean, if for some reason your data pipeline just craps out on you, or I mean, for whatever reason that the corrupted data might have gotten in there, you can always trace back to a point or a model, a model at a point in time in which, right, you're confident that yes.
At the time before this new data set was related.
Yes. Yeah. And if for some reason you couldn't, that data's kind of just stuck there for now. You can always, like I said, filter that data out in future model training. But yeah, I mean, it doesn't solve, right, the cleaning of the database for you, right, or cleaning out your data store, but it'll at least give you the tool to the tools to be able to. I mean, right. So if you've deployed a previous model that you trained, it'll give you some time to investigate. Yeah.
I'm wondering how does it handle comparison, say Delta and
So I mean, right. So in this case, I mean, one way would see kind of what scores produced for these, but I mean, again, that kind of depends on how you want to model this comparison. Yeah.
or say Alaska is better than
don't have a good answer, but I mean, right, I guess you could always, in a sense, right, take the scores that you produce, kind of compare different distributions of scores, and there kind of get, I mean, just purely on eyesight, right, or I mean, do some sort of comparison between the two distributions. I guess, I mean, right, if you have like a set that you know is related to delta, right, so if delta is contained in the text, get that distribution of scores.
Like,
yeah.
say like compare like a delta has like 90% of negativity, and then like Alaska has 90% of positivity. And then,
Yeah, so I mean, I would say like one way to do it, at least in this setup here, would be, right, so let's take a look at the distributions of, yeah, but basically like yeah. So let's take a look at the distribution of neutral, negative, positive, and kind of how that compares to the actual the distribution between the two, right? So I mean, at that point, we're just doing some sort of comparison of the two distributions.
Well, I was going to add, I think the critical part of this is that your training data and your algorithm and saying positive, negative, neutral is based on very specific criteria. For example, your example was, do they have a positive or negative or neutral experience with my airline? Not comparing it. So
Yeah.
you can't, it's apples and oranges at that point. Right?
Yeah.
You see, so I think what you would have is in your example here with your deployment engine, is that would be where you would have one set of training criteria is positive, neutral, negative with my airline. One might be across airlines, and even then you'd have to be very specific, I think, of, for example, I routed from San Francisco to New York. That would be very, that's where you get more accuracy. If you start taking one model, and this is the fallacy, and I start applying it, well, it's a machine learning across X question, I mean, you're literally, you're making it up at that point, and that's my bias kind of problem as well. You have to be very specific about its data that you've evaluated for a very specific question, and that's the question you're answering. You cannot go across questions, right?
Yeah, so I mean, so in this case, right, like we're being given, I mean, we can't differentiate in the data, like, I mean, I guess we can differentiate whether or not it contains it, but like the thing is like whether or not this tweet had a positive, neutral, or negative sentiment.
About what?
About, yes.
And then what I love about your deployment is your A/B testing, right? So what you're able to do here is say, okay, I think I have one set of data. So let's go back to the bias question. Imagine for a scenario where you say, I feel like there could be bias. So maybe you've gone to a third party and had them reevaluate the tweets to determine neutral, positive, negative. And then you do that as your B. Now what you're able to do is do another set of criteria of saying, for example, of people who I thought were negative, did they rebook with my airline in the next 6 months? Right? If they were a casual traveler, they come back maybe the next 3 years.
Yeah.
If they're a business traveler, it's literally within the next 2 months. And then you're determining was A or B better, because what you're trying to do is get your model even more accurate than it was before. That's what's really cool about this.
Yeah, and it gives it basically, I mean, it lets you do it, right? Because I mean,
in real time.
Yeah.
Right? So what you're showing is that's what you're trying to accomplish at this stage of the game, right?
Yes.
Yeah, that's awesome.
Question. So once I've found the optimal.
Actually, can everyone? Yeah. Let's pass it back.
So once I've found the optimal hyperparameters from cross-validation, and I'm doing a model ensembling, can I also do a grid search or something on the model weights that would give me the best accuracy in the whole pipeline?
So actually here, so actually I haven't gone over the eval stage, but so the way that we do the evaluation here, right, so over here we have to define a metric from which we're using to compare the models. So in this case, just simple accuracy, as you can imagine, you can compute other metrics here. And then over here, so we do a grid search on there. So not as much, right, so I mean, depending on how you want to encode your weights right, because the hyperparameter here in this case, like say for the logistic regression, is going to be that right? That regularization parameter, right? But yeah, I mean, so long as you can formulate this. Yeah, right. So I mean, I guess in this particular case, no, it's not doing a grid search over weights, over your model weights. But it's right. So where the evaluation is going to come in is what, right, at what level on this real number line is this going to produce the optimal set of weights?
So, I mean, later in the pipeline, once I've kind of gone through this stage, the next stage would be, okay, I know what those best parameters for each of the models are. Now I want to see, do I want to put 70% from night-based and 30% from logistic or whatever that needs to be, that weight assignment. Can I do that in the workflow or no?
Yeah, right. So at that point, right, so I've like, after you've seen kind of how people react to this and now you have some prior beliefs as far as to how to combine these, then yeah, I mean, you can at that point, right, so if your scores are producing probabilities and you can define this to be just some sort of mixture based on the prior beliefs that you've observed, I mean, from how your customers are reacting to the different models. And again, the different deployments can give you an idea of how your customers are going to react.
We're around the one time.
Okay, cool. Sorry. Awesome. All right, so I guess I'll show you the eval real quick. So once we've set that up there, dope. So yeah, and as you see, for the actual evaluation, we just need to specify basically what class we're using to compute the metric, and then what set of engine parameters, and then it actually goes through and does all this for you. Yep. And then as you can see, it actually prints out the best producing result. And it actually does go through and modify the engine.json for you so that at that point, right, you can now just go ahead and deploy, and it'll deploy the model, the best model that was found. Cool. So yeah, so I think the main thing I want you guys to take away from this is really like how easy it was for me to actually, right, so literally going in from the template, I had to modify very few lines in the actual code to get this thing to work. Like I said, the toughest part was actually parsing the CSV and putting it in JSON format. Right? And now we have something that compiles your project, does the training for you on a distributed environment. So actually, does it very. So it's using a local Spark master here, however, right? But you can specify what Spark master you want to use it to, and so it scales. And right, the biggest thing also is, I mean, just the way that you can just automatically deploy these engines and use them as REST services, right? And you can deploy different kinds of engines, these variants that we have, right? For, say, A/B testing, right? Connecting two different prediction results using some, right? So you can, as you can imagine, right? You have an HTTP service that's saying, okay, I take in this request based on the type of request, right? Hand it off to this model, and then this guy responds back with, say, another certain response, and then once we get that type of response, right, then deliver it out to this next model, right? So I mean, as you can imagine, right, these things are now just services that you can just query via curl, right? Cool. So I'm going to go ahead and leave it up to questions now.
One or two quick questions, Mark.
Yeah. Any more questions? No?
Guess we asked to take questions offline then.
Sounds good.